In this video, we continue our work with word problems that use quadratic equations, and we're going to look at word problems that involve some sort of geometry. So in this first example, you have the length of a rectangular garden is 8 feet longer than its width. If the garden's perimeter is 180 feet, what is the area of the garden in square feet? So again, we've got a lot of things that are given here. One of the things that would help is maybe to go ahead and draw a rectangular garden. So I'm going to draw a little rectangle here to help me. Just like that. Okay, good. And what do we know about the dimensions? Well, we know that the length is 8 feet longer than the width. So let's let W represent the width. That's the dimension we don't know anything about. And then the length is going to be 8 feet longer than the width. So we're going to use the expression width plus 8 feet, right? Okay, so we've now defined our variables. Again, W is the width of the rectangular garden in feet. And then W plus 8 is going to be our length. Okay, now we need an equation. And we know something about the garden's perimeter. So I'm just going to remind you that the perimeter of a rectangle is the sum you get when you add up all four sides. So perimeter, add up all the sides, right? And we have, of course, W is the width, and we have two of those, right? So 2 times W, 2 widths, added to 2 lengths. And our length is this expression W plus 8. So 2 of these, and that has to equal our 180 feet, which is our perimeter. Okay, so this is a linear equation so far, right? So we're going to go ahead and distribute the 2 here. And so we have 2W plus 2W plus 16 equals 180. Combining like terms, we get 4W, and then we're going to subtract the 16 equals 164. And then we're going to divide by 4. And so we get that W equals 41 feet. Okay. Now, we're asked to find the area of the garden. So once we find the width, let's go ahead and find the length. And you remember that the length was 8 feet longer than the width. So 41 plus 8, which is 49 feet. And now for the area. So we have to remember that the area of a rectangle is length times width. So we're going to multiply the 49 feet times the 41 feet. And our area is going to be in square feet, right? So I'm going to go to my calculator. And 41 times 49 is 2009. So the area of our garden is 2009 square feet. Okay, let's go to the next one. So we're back to a rectangular park. And we know that the length of the rectangular park is 4 feet less than 3 times the width. The area of the park is 219 square feet. Find the width and the length. Oh, and round your answer to the nearest tenth of a foot. Okay, so again, a picture may help. So here's our rectangular park. We're going to define variables. Again, we know nothing about the width, so we're going to let W represent the width. But now for the length, we know that it is 4 feet less than 3 times the width. So 3 times the width would be 3 times W, right? And we want 4 feet less than that, so subtract 4. Okay, so W is the width of the park in feet, and 3W minus 4 is the length of the park in feet. Okay, now we need an equation, and the only other information we know is about the area. The area is 219 square feet. the area of a rectangle is length times width. So we're going to, so again, area equals length times width. So we are going to put 219. That's our area in square feet. The length is 3w minus 4, and the width is w. So there's our equation, right? And if you want to rearrange it, we can. So we'll do that. We'll rearrange. But as I rearrange, I'm also going to distribute this w here. Okay, so I'm going to get 3w squared minus 4w equals 219. Okay, this is a quadratic equation, so we need it in standard form. We need a 0 on one side, so I'm going to subtract the 319. I'm going to put it over here. And I'm going to use quadratic formula to find w. So, do you remember the quadratic formula? A, see I'm looking here at the quadratic, A is 3, B is negative 4, and C is negative 219. So w, because our variable is w, is the opposite of b, which will be the opposite of negative 4 or a positive 4, plus or minus square root, big square root. And then b squared, which is negative 4 squared, would be 16, wouldn't it? Negative 4 times negative 4 is 16, minus 4, and then 8 times c. So we have this 3 times that negative 219, which is negative 657. Okay, and that's going to be all over 2 times a, which is 2 times 3, or 6. All right, let's do some simplification under the square root. We're going to multiply first the 4 times the 657. That's going to make this, see how there's two negatives here, minus 4 times minus 657, because we have to do that multiplication first. And then we're going to add the 16. So let's do that to work. So that would be 2,644, which I did in my calculator, and then that's all over 6. Okay, now see how the question says round answer to the nearest tenth of a foot? So let's go ahead and use our calculator to get this approximation here. And notice I'm not going to use the 4 minus square root because that's going to give me negative width. Remember, we're solving for width. We can't have a negative width. So our w is going to be 4 plus square root of 2644 all over 6. So I'm going to get the calculator and let's get that decimal approximation. Okay, so I went ahead and put in our quadratic formula there, the 4 plus the square root of 2,644. Notice that's in a parentheses, divided by the 6. And so I got 9.2. They want this rounded to the nearest tenth of a foot. So 9.2 feet for the width. And then let's find the length. So we have w equals 9.2 feet. And then I went ahead and substituted 3 times w, subtract 4, which is our length. And that gives us 23.6 feet. And then let's quickly just check that in the calculator that our area is supposed to be 219, right? Yeah, see how it says the area is supposed to be 219 square feet. So let's multiply that in the calculator and see if we get close to 219, right? Because these are approximations. And see, notice that we get 217 as an approximation to the area. Okay, let's go to the next problem. Okay, this problem involves the use of a triangle. So it says that the base of a triangle is 8 inches more than 3 times its height. The area of the triangle is 190 square inches. So what is the height and the base? So what are the base and the height? Okay. So first of all, let's remind ourselves and what the formula for area of a triangle is. And so the area is 1/2 the base times the height. Okay. And if we draw a little triangle here, then it's telling us that we know nothing about the height, right? We need to know something about the base. Oops. We know something about the base, but we don't know anything about the height. So the height, this is our, I'm going to call that h. That's going to be our unknown, okay? And the base is 8 inches more than 3 times the height. So 3 times the height would be 3h. And then if it's 8 inches more, then you add 8. So there's the picture that shows our triangle. And we're going to substitute into our equation. Now the area was given, it was 190 square inches. So I'm going to write 190 equals 1/2. And then the base is this quantity, 3h plus 8. And the height is h. Okay. Now one of the things that I don't like is this half here. So what I'm going to do first to make life easier is that I'm going to multiply by 2/1, the reciprocal. I'm going to multiply by 2, okay? Because then here I'm going to have a 1. 2/1 times 1/2 is 1. So I'm going to have 3h plus 8 times h, and then over here I have 380. Okay, but now I don't have a fraction, so I like that. Let's distribute the h. Put over here. So 3h squared plus 8h, and then I'm going to subtract that 380 equals 0. Okay? All right, so now these are big numbers. Shall we do quadratic formula? Let's do that. All right, so h equals the opposite of b. So b is your positive 8, right? So the opposite of b plus or minus square root b squared, which is 8 squared. So that's 64 minus 4, and then 8 times c. That's a big number, isn't it? 3 times negative 380. So I think we need to get our calculator back out. So let's get our calculator back out. Okay, so that was what? 3 times 380, so 1140. Negative, right? All over 2 times a, or 2 times 3, which is 6. Okay, so let's once again, let's go ahead and use the positive root of this. So we're going to go ahead and use the calculator since it's here. And so we get, I'm going to actually simplify that radicand, that discriminant. If you remember that that's what is called, the radical, what's inside the radical in a quadratic formula. So I'm going to write, I'm going to figure that out first. 64. And then I have minus 4 times negative 1140. Okay, let's see what that gives us. That gives us 4,624. So we're going to take the square root of this guy, right? So let's do that. So let's actually do the whole thing. We're going to do negative 8 plus square root 4624 divided by the 6 and see what we get. Oh, we get 10. Nice. So h equals 10. Okay. And so then that's our height. So then what's the base? Well, remember the base was 3 times the height plus 8. 3h plus 8, right? So 3 times 10 plus 8, so 38. So 38 inches, right? And the height is 10 inches because everything's in inches in this problem. Yes? And so let's check that. Will that give us one, if we do the area, if we do 1/2 of the base times the height, 1/2 of 38 times 10. So yeah, let's see, 1/2 of 10 is 5. 5 times 38 is 190 square feet. So that works. Good. Let's go to the last problem. Okay, in this last problem, we have the sun casting a shadow of a flagpole. So this, here's the sun. Here's the flagpole, okay? This is the ground, right? This is the ground. And so when the sun hits the flag post, right, it'll hit it like this, and there will be a shadow. So this will be the shadow, okay? And this is the pole. I just want you to visualize this. All right, and so you can see that this is a triangle, can't you? So we've got a nice little triangle happening here. Okay, there's our triangle. And it's telling us that the length of the shadow is 2 times the height of the flagpole. So we do not know anything about this height. So let's call that h, right? H for height. And then the length of the shadow, well, that's this side. This is this horizontal, right? And it's 2 times the height of the flagpole. So 2h. Okay. Then it says that the distance between the end of the shadow, which is here, right? Here's the end of the shadow, and the top of the flagpole, which is here, that this distance is 78 feet. So now if you recognize a right triangle, you're right. Okay. And so how are these sides on a right triangle related? Well, if you're thinking Pythagorean theorem, you're absolutely right. So I'm going to write that down. And Pythagorean theorem tells us this is this famous a squared plus b squared equals c squared, where c is the hypotenuse. That's that long side. Okay? A and b are legs. We call those the legs. So in our case, h and 2h are the legs. 78 is the measure of the hypotenuse, right? So we're going to go ahead and simplify. Substitute. So h squared plus, now this 2h needs to come in a parenthesis because we have to square that. That's going to equal 78 squared. Okay, so let's go ahead and square here. So we have h squared plus, now squaring 2h is 4h squared. All right, and then 78 squared, 6,084. Okay, I used the calculator. All right, and so then here you have like terms on the left. So this is 5h squared. 5h squared equals 6,084. And notice that we have a quadratic here with no middle term. So we can use square root property. So let's divide by the 5 first. And then we are going to have h squared. And I'm going to go to the calculator in a minute. I'm going to do this division, right? And then I'm going to take the square root, right, of whatever this guy is. Okay, and then notice that this time around, usually when we do square root property, I would say put a plus or minus here, but height is positive, right? So we need to just look at the positive. They want this answer rounded to the nearest tenth of a foot. So let's go to the calculator and do that math. All right, so I went to the calculator and I took the square root of 6,084 divided by 5, and I got 34.888, 8826, etc. But they wanted these answers to the nearest tenth, so that's about 34.9 feet for our height, the height of the flagpole. And then remember that the length of the shadow is twice that. So we multiplied by 2, and that gave us 69.8 feet. Hope that helps.